Okay, so in this video, we're continuing on with our toolkit function. So if we were to take a look at the reciprocal function here, we can see that this would be a one-to-one function because it would pass the horizontal line test. And so the domain of the original function is going to be negative infinity to 0, and then from 0 to infinity. Remember that is a restriction at 0, right? X cannot equal 0. That's going to end up being a vertical asymptote. And then our range, of course, is going to be, again, the same thing, negative infinity to 0, and then from 0 to infinity. Since this is a one-to-one function already, the domain of the inverse is going to be the range of the original. And so we have everything except 0. And then, of course, the range of the inverse is going to be the domain of the original. So negative infinity to 0, and then from 0 to infinity. So let's take a look at the function of the reciprocal squared. So the reciprocal squared is going to be just like that reciprocal function, except that this, what would normally be in quadrant 3 is actually reflected up against in quadrant 2. So this is not one-to-one. You can see that it would not pass that horizontal line test. So what we need to do is go ahead and restrict it so that it will be a one-to-one. So what we're going to do is restrict the function so that it represents this guy right here in quadrant 1. So the domain is going to be from 0 to infinity, and the range is going to be from 0 to infinity. And the domain of the inverse is going to be the same as the range from the original. And the range of the inverse is going to be the same as the domain from the original. Let's take a look at the cubed root. The cubed root is going to have this kind of like inflection point here, and it is a one-to-one function. The domain is going to be all real numbers, and the range is also going to be all real numbers, and same way with the domain and the range of the inverse, since they just switch. All right, so the square root, if we notice the graph of a square root, that definitely has a beginning point. So we have the domain that is going to be from 0 to infinity, and the range is also going to be from 0 to infinity. And it is a one-to-one function. And so the domain of the inverse is the range of the original. And again, the range of the inverse is going to be the domain of the original. And here we have the absolute value of x, and that is not one-to-one. So what we need to do is restrict it so that it is a one-to-one function. So the domain on that is going to be from 0 to infinity, same way with the range. And then now that we've restricted it, the domain of the inverse is going to be the same as the range. And then the range of the inverse is going to be the same as the domain of the original.